Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. In this video we will continue the explanation of the complex numbers. We start by an activity. To solve the equation x squared minus 9 equals 0, you have to factorize the first number of it. X squared minus 9 can be written as x squared minus 3 squared, which is x minus 3 into x plus 3, in the form of a square minus b square. So x minus 3 into x plus 3 equals 0. You get x equals 3 or x equals minus 3. X squared plus 9 equals 0 doesn't admit real solutions, because x squared plus 9 cannot be written in the form of a difference of two squares. So you have to write x squared plus 9 in the form of a squared minus b squared in another set, in a set bigger than the set of real numbers. How? We write x squared plus 9 as x squared minus 9. So we think about an imaginary number called I. This is an international notation. I square equals minus 1. So when we substitute minus 1 by I square, we get minus 9 is 9i square. 9i square, because I square is minus 1. X squared minus 9i squared can be written as x plus 3i into x minus 3i. So take it equal to 0. We get x equal minus 3i or x equal 3i. 3i and minus 3i are complex numbers. In general, if we take the equation x minus a square plus b square equals 0, the x minus a square plus b square can be written as x minus a square minus ib quantity square, like this. X minus a square minus ib square. I square equal minus 1. We go back to what? To plus b square. This is x minus a minus ib into x minus a plus ib equals 0. You get x equals a plus ib or x equals a minus ib. The solution is in the form real plus I real number. Algebraic form of a complex number. The algebraic form of a complex number is z equal x plus iy, where x and y are real numbers. X is called the real part of the complex number z, and y alone without I is called the imaginary part of the complex number z. The image of a complex number is the point in orthonormal system of coordinates x, y, and z is called the affix of the point M. Z bar equal x minus iy is the conjugate of z equal x plus iy. Z bar equals x minus iy. If z equal x plus iy, the conjugate of z is z bar equals x minus iy. Example: if z equals 2 into 1 minus 3i plus I into 2 plus 3i, we have to write the z in the form of x plus iy, where x and y are two real numbers. Multiply 2 minus 6i plus 2i minus 3, because I times I square equals minus 1 minus 3. 2 minus 3 minus 1 minus 6i plus 2i minus 4i. The real part of z is minus 1 and the imaginary part is minus 4. And the image of the complex number z, this is the algebraic form. M minus 1 minus 4 is the image of z. Z bar equals minus 1 plus 4i. You have to change the sign of the imaginary part. And its image is the point of coordinates minus 1, 4. So real and imaginary parts of a complex number. Z equal a plus ib or a plus bi, the same. The real part of z is a and the imaginary part of z is b. Remark: the image of z and of z bar, the image of z and the image of z bar are symmetric with respect to x prime x, because if z equal a plus ib, the coordinates of its image is the point a of coordinates ab. Z bar is a minus ib, its image is the point of coordinates a minus b. Plot the 2 points in orthonormal system ab, a minus b, so that images are symmetric with respect to x prime x. If z equal 5i minus 2, we write z equal minus 2 plus 5i, a plus ib, or a plus bi, the same. The image is the real part is minus 2 and the imaginary part is 5. Write in algebraic form each of the following complex numbers. Z equal 2 minus 3i into 2 plus 3i. This is the form of a minus b into a plus b equals a square minus b square. A square is 2 square minus b square minus 3i square. But I square equal minus 1. Minus 1 times 9 minus 9 minus plus 9. 4 plus 9 equals 13, which is a real number. When we multiply a number by its conjugate, we will get a real number. Z equals 3 plus 4i into 3 minus 4i. Also the complex number by its conjugate. When we multiply, we get 3 square minus 4i square. 3 square minus 4i square. But I square equals minus 1 minus 16 plus 16 equals 25, which is a real number. Z equal 1 minus 2i over 1 plus 3i. We have to write z in algebraic form. We multiply up and down by the conjugate of 1 plus 3i. Because when we multiply 1 plus 3i by its conjugate, we get real number in the denominator. One minus 2i into 1 minus 3i, we multiply, we get 1 minus 2i minus 3i minus 6. Why minus 6? Minus 2i times minus 3i plus 6i square. But I square equal minus 1 minus 6. And 1 plus 3i into 1 minus 3i, this is equal 1 plus 1 square plus 3 square equals 10. Minus 5 over 10. Minus 5 over 10. 1 minus 6 minus 5. Minus 5 over 10 plus minus 5 over 10, which is half minus half plus minus half I. The real part is minus 5 over 10 or minus half, and the imaginary part is minus 5 over 10 or minus half. Determine the image of each one, of each complex number. In the first example, z equal 13. So 13 plus 0i, then the image is 13 0. In the second example, the second part, z equals 25, then its image is 25 0. The third part, minus 5 over 10 plus minus 5 over 10 I, so the image is minus 5 over 10 minus 5 over 10, or minus half, the same. Thanks for following and good luck.